Welcome to this discussion of the electromagnetic spectrum and some applications that utilize electromagnetic waves. The higher end of the spectrum is composed of high-frequency ionizing radiation that includes gamma rays, X-rays, and ultraviolet light. Towards the middle of the spectrum is the very small portion of visible light that we can perceive, and at the lower frequency end of the spectrum is non-ionizing radiation that includes infrared, microwave, and radio waves. Gamma rays are produced by the hottest and most energetic objects in the universe, including radioactive decay, astronomical events, nuclear explosions, and lightning. This radiation is primarily used in astronomy, geology, and medicine. Since gamma radiation is highly penetrating, tissues and organs of humans exposed to these wavelengths at high doses are damaged immediately. X-rays are lower in energy than gamma rays. Some of the most common applications of X-rays include X-ray astronomy, spectroscopy, crystallography, microscopy, airport security, fine art photography, and medical imaging. Since X-rays can damage or destroy living tissues and organisms, it is also used in medicine to destroy cancer cells. Between X-rays and visible radiation lies the ultraviolet range. The sun is the most important free source of ultraviolet light, known for its ability to activate vitamin D production in the skin. UV wavelengths are also used in forensics, barcode tracking, disinfection, solid-state lighting, bug zappers, and ultraviolet photography. There are three types of UV radiation differentiated by their frequency: UVC, which is entirely screened out by ozone, UVA, which reaches the Earth's surface but is not genetically damaging, and UVB, which reaches the Earth's surface and is a major cause of skin cancer in humans, can cause eye damage, liver spots, and premature aging. UV light is used in reflected UV and fluorescent photography, which is used in medicine, criminology, camouflage detection, theater, and the examination of works of art. Visible light are the wavelengths that humans can perceive. This light is used by telescopes, lasers, microscopes, photography, medicine, and electronic devices that have viewable screens, such as MP3 players, touchpad devices, LCD monitors, cell phones, and TV screens. The full spectrum of visible light includes all the colors of a rainbow. The colors perceived are reflected wavelengths, not absorbed. Digital cameras can recreate the color images we see by using a sensor that captures and records the brightness values of red, green, and blue light as numbers and processing them into an image. A technology in medicine that relies on light is fiber optics, which enables physicians to view and work inside the body using only a small incision and no surgery. The infrared portion of the electromagnetic spectrum can be divided into near-infrared and thermal infrared. These wavelengths are used for IR data transmission, spectroscopy, meteorological scanning, optical astronomy, chemical imaging, thermography, night vision, art authentication, heating, and photography. Longer wavelength IR, also called thermal IR, has the ability to raise or maintain temperature and is a more penetrating radiation than visible light. Heat from these waves can be sensed by IR detectors such as infrared cameras and night vision goggles. These infrared waves can then be used to create a thermal image called a thermogram. Some digital equipment is also sensitive to specific wavelengths in the IR. IR transmission can be used by remote controls to change channels on your TV, VCR, or DVD. The full range of light in the electromagnetic spectrum can be captured by modified digital cameras and telescopes. Microwaves are the backbone of the Earth's communication and sensing systems. These waves are used in spectroscopy, navigation, astronomy, heating, power transmission, radar, and communication. Their applications include voice and data messages, linking between broadcast or cable TV stations, wireless LANs, Bluetooth, mobile phones, and transmitting antennae. Radio frequencies have the longest wavelengths and the least amount of energy in the electromagnetic spectrum. These waves are commonly used for radio transmission. Different ranges of these frequencies are divided into bands. These bands are typically regulated, sold, or licensed for specific transmission technologies and applications in order to prevent interference and facilitate efficient delivery of communication. In summary, we have seen how the electromagnetic spectrum offers us comfort, convenience, information, and health. We've also seen how radiations in this spectrum must be respected since, quote, Any amount of radiation may pose some risk for causing cancer and hereditary effects, and the risk is higher for higher radiation exposures, unquote. Therefore, the better we understand these spectral emissions, the more efficiently we will be able to both harness their energies and safeguard the welfare of ourselves and others.